I know we're running a little bit behind schedule right now, so I'll do my best to make things go even longer. I want to do my share. I will talk about BioBran, but perhaps in a different context than what you may have heard before. And because you are people that are interested in the promotion of this product, both from the standpoint of marketing, but more importantly, for the improvement of human health, I want to review some familiar information and then progress on into some areas that may create greater opportunities for you to be able to present this product towards that opportunity, that goal of greater human health in your regions or whoever you might come in contact with. Often, like Mr. Sasaki mentioned, I find myself on an airplane sitting next to someone and they're complaining about some health issue in their life, or perhaps someone in their life, in their family. And I know that BioBran is helpful for that, so I end up talking about BioBran all the time. I get to the point now where in my carry-on luggage I always carry samples of BioBran, or actually in my case the Peak Immune 4 and BRN4. As I travel more in Europe, hopefully I can find some BioBran samples so I can hand people samples that are actually relevant to their region of the world. I hope you'll be able to see this well with all the lights. Is it possible to get rid of those lights over there since we don't need those? So in this talk, and it's titled Reversing Immunosenescence to Eliminate Cancer, Heart Disease, and the Major Chronic Diseases of Aging. And I'll talk about what immunosenescence is and how taking BioBran can naturally reverse immunosenescence, and also how taking BioBran can restore our human immune power so we lead longer, healthier lives. So, to start out with, what is BioBran and what does BioBran do? And as all of you know, BioBran is a product based on what's called RBAC, rice bran Arabinoxilan compound. And it's a natural immunomodulator that was developed in Japan around 1992 by Dr. Hiroaki Maeda. And it's an organic compound. Now, every country has its different culture. And in each culture, there are favorite words and expressions. And as Monica mentioned, my background is both in organic chemistry and as well in medicine and research and all that. Well, when the whole organic movement first came out, I was very much against it. You know, like many of you mentioned, these classically trained doctors and physicians. But I was against it for a completely different reason, because as an organic chemist, I said, well, carrots have always been organic. And so what are you telling me when you say that this carrot is organic? Because organic just simply means something that's produced by a living species on the planet anywhere. Carrots are live, carrots are always organic. It wasn't until the Organic Food Act of 1990 in California where they started to describe organically grown food, then I thought, okay, I can understand this. Then I understand they're not talking about that one carrot is organic and the other one is non-organic, because it would have to be made out of metal in order to be non-organic, but rather the way that it's grown. It's important the type of information that you bring to people and how you present it to people so that you can understand what they need to hear in order to communicate that bit of understanding. Once I understood what the difference was between the types of carrots, and I used to drink a lot of carrot juice when I was in medical school, we lost our slide projector. I switched my source of carrots for my carrot juice to organic carrots exclusively, and understanding how plants grow and how root crops draw in molecules like pesticides and store them inside, because that's the purpose of a root, is to store energy. Then I realized juicing it was basically just kind of distilling out all of the worst things that we put in a crop. The point being, though, that understanding what some of these terms are that we use. While I'm waiting for the slide to come back up, I just want to address one thing that I heard mentioned more than once, actually, in prior presentations, and that's that concept of This always happens. You don't know how many times I give a presentation and the filters, and I think it's because air quality around the world is getting worse. Anyway, I challenge you to take away some of the magical authority of scientists and physicians. And I know as a person who is both of those and who is also just a regular human being, and as you go through school, we kind of part ways. And the people that are studying quantum physics and vector calculus and molecular biology go off in one direction, and the people that are studying politics and economics and those sorts of things go in another direction. And so there's this sort of mystique like you would have with priests. But you always need to challenge these people to validate what it is that they're saying, just like they challenge you. Because much of the time, what scientists and physicians say is merely posturing, and it's not actually valid. It is not valid. There's no such thing as a classically trained physician or a scientist who has a bias against natural or alternative medicine or BioBran or any of these products, for one very clear and simple reason. Because a classically trained physician and scientist would have no bias. There's no basis in science for bias. You always look at the data. There is no basis for having a prejudice or a presumed conclusion. Just because something comes from nature or comes from the rainforest or whatever, it doesn't matter. The bottom line is efficacy. And if it is efficacious, then that's all that you care about. It doesn't matter if it comes from AstraZeneca or from an old man who just came out of the woods. That's not the point. The point is whether or not we are able to help our patients. Anyone who has a bias has actually transgressed on their oath as a physician and has digressed from their training, that so-called classical training. I mean, the most classical of classics, right, is, the usual classics of Greco-Roman classics, right? And those people used natural medicines. It's only very recently that, as they say, the chemists have started to think of themselves as being greater chemists than the chemists that created them. It's the last 50 years, 60 years. And especially in the area of cancer, because no one has a cure for cancer. So there's no basis for boasting. There's no basis for bragging. How can they say that your product doesn't work? Well, have them show you theirs that does. And where's their product that works for AIDS, for hepatitis, for influenza? If there isn't one, every physician should be looking for every opportunity to help those patients, regardless of where it comes from, as long as it meets the first statute of the Hippocratic Oath, which is first do no harm. BioBran is non-toxic. It does no harm, especially when you give it to people for free. So that is the one point I want to point out regarding that concept. If someone has a bias, do not honor them by calling them classically trained. They're just contemporarily biased. So, with respect to words, here, as I mentioned in describing BioBran, it's an organic compound that's produced by the enzymatic action of purified hyphomycetes mycelia enzymes upon whole grain rice bran. And this is primarily shiitake and also, I think, the enoki mushrooms. But the key point here is that BioBran is organic. That is an important buzzword in the modern world. It's produced by a natural process. And so those words natural and organic actually apply to BioBran, even though it may not be certified organic as a food, because that's a different concept. So if you say that this is a certified organic orange, okay, that means that it should be grown a certain way. But as I said, all oranges are organic. All rice bran is organic. And it's all natural. So the process of creating BioBran, of creating the basic ingredient, which is rice bran, Arabinoxilan compound, or in this case I use the word polysaccharide because that's the type of molecule that it is. Polysaccharide, poly meaning many parts, and saccharide meaning sugars. And of course sugar is a bad word in the world. Again, it's one of these words. Organic, natural, those are good words. Sugar is a bad word. So I have to tiptoe around in most audiences to try and talk about this part of it, because when I say, well, these many parts here, as soon as if I say that there's sugars, then suddenly people are afraid that, oh, well, when I take BioBran, I'm taking sugar. Sugar is bad, and so that's an issue. And we have lots of prejudices in our superstitious world. As much as we think we're very modern and erudite, we have lots of backwards thoughts. But crude rice bran is made up of a huge molecular structure, primarily if you look at the hemicellulose part, which is where RBAC comes from, primarily Arabinoxilan, modified Arabinoxilan, and it's this branched chain polysaccharide, meaning that it just kind of sticks out in every direction, but it's very long, and it's a huge molecule, and that molecule, like any large molecule, is difficult to be absorbed into the body, okay? Which is where the primary area in the human of immune response and immune stimulation is inside of the bloodstream, even though there is some in the GI tract. So in this state, this crude rice bran is primarily similar to dietary fiber, which of course has a laxative effect, regular rice bran. It has no access, as I mentioned, to the immune cells in the bloodstream, and with this transformation of enzymatic hydrolysis, though, you create what chemically would be called an Arabinoxilan oligosaccharide, which is bioavailable, which is something that can actually, once you ingest it and it's in your stomach, it actually is able to cross through the barrier between your intestines and get into your bloodstream, where it's able to have the type of activity that we've observed with natural killer cell activation, etc. And that, again, at least by hypothesis, is because the RBAC molecule is smaller and therefore leads to higher absorption. And of course, remembering RBAC is just the generic name for BioBran. An important thing to remember about the human body that perhaps everybody knows, or perhaps it's a good point to refresh, is that your digestive tract is not inside of the body, it's outside of the body. We usually think of that as being inside of the body. And a way to describe that to you is to look at my hand. Now, if I have my hand here and I put my laser pointer and my flash drive, is it inside of my hand? Is it inside of my body? Or is it just sitting there? Okay? It's not actually inside of the flesh of my body, it's surrounded by my hand. It's the same way with the digestive tract. The digestive tract is just an extension of all of this skin that's outside of your body, and it enters into the mouth and it goes through a tube all the way through to the other side. So it's like you have, your body is like a channel, like this, okay? So what you put in the mouth that comes out the other end, it has never entered your body. It's just sitting there like this is inside of my hand. So if this was an aspirin tablet, it wouldn't get rid of my headache just by me holding it in my hand unless it had some homeopathic properties, okay? But it needs to be absorbed, okay? It would need to pass through this barrier of my skin. It would need to soak in, okay? And in order to do that, the pill would need to dissolve, it would need to become liquid, it would need to be able to pass through the pores of my skin. It's the exact same thing in digestion. And in fact, the inside of the lining of the stomach, the intestines all the way through to the other end, it's all actually the same type of tissue. It's just skin. You're surrounded by skin all the way around. It's just slightly different once it gets into a moist area, like inside of the mouth and the rest of the digestive tract. So, this concept of immunorestoration, of empowering the immune system, and taking AIM, and I will use this acronym quite a bit throughout this talk and explain it a little later. But this is a diagram that I created which shows rice just before harvest season as it's ripening, and this is the molecular model structure of the proposed active ingredient of rice bran arabinoxilan. This is an oligo-arabinoxilan molecule. So, in order to understand this work, one question is, and has come up today, what dosage of BioBran works best? And to take the best aim, BioBran, we have over a decade of scientific studies that have shown that RBAC is a high specificity short chain arabinoxilan, that's the molecular description, AIM, and derived from rice bran. And as I mentioned, I'll describe what that actually means, what AIM is, that acronym. But its activity is that it modulates NK cell, T cell, B cell, and global immune system functions in a dose-dependent manner. This part right here is very important to physicians that actually know anything about pharmacology, because you want whatever it is that you're taking, it should show an increased effect with an increased dosage up to a certain point. If not, then it's not actually functioning according to standard concepts of pharmacology. okay? It's functioning by a different mechanism. It doesn't mean that it's effective. It doesn't mean that it's not effective, but it just means that it's not following that pharmacologic model, in which case all of those assumptions don't apply. But in this case, we do have a dose-dependent effect. When you don't have one, it's much more challenging to convince people that what you're giving is actually more than just some product that's the equivalent of a hug, but that you're actually giving something that has a familiar type of effect on the body. So, among the various polysaccharides, including mushrooms and all sorts of other products that people take for immune stimulants, BioBran has been shown in human studies to be the most effective in activating natural killer cells and optimizing immune function when taken orally, and this could be before or after meals. Here's the graph. Dosing guidelines. For specific health concerns, now these are the recommendations that I make in the United States, and they don't have to supersede what you make in your own country, but perhaps there's some valuable information in it. For specific health concerns, this is how I phrase it. I don't talk about diseases in general. I don't talk about treating cancer or HIV or any of those things, because one, that's on the other side of the taboo line, and I don't find it necessary. If I have enough time to speak to someone clearly and they're paying attention, disease actually becomes irrelevant. Diagnosis becomes irrelevant. But 12 capsules a day, which is 3 grams, which of course you can translate into your packets. And that's for 1 month, after which then they would reduce to 4 capsules a day, or 1 gram. And for general immune support for a healthy person, the general recommendation is 4 capsules a day. And again, these are general guidelines. And of course, the status of a person, and if they're undergoing chemotherapy, and as the representative from Germany mentioned earlier, that he recommends, I think you said 5 packets, that's 5 grams, wouldn't it be, a day? The specific condition of a person with respect to their ability to absorb the BioBran, what's the condition of their GI tract? When people are receiving a lot of chemotherapy and radiation therapy, their ability to absorb nutrients is decreased. So it's not necessarily in conflict with this to give 5 grams a day. It's really important to understand how any sort of agent, a drug, a product like BioBran, anything that's being absorbed into the body to have a pharmacologic action is very important to understand how that works. It's limited by lots of factors. It's affected by the person's emotional state. The emotional state affects blood supply to the GI tract, which then affects the rate at which something is taken into the body. It's affected by their dietary habits, all sorts of different aspects. And so these are very general guidelines, and it's important if the person has the opportunity to have a healthcare provider that's willing to monitor their progress and actually is paying attention to their BioBran dosage as opposed to just saying, oh, that's one of those weird things that I don't pay attention to, then you have an opportunity to optimize the dose. My training in medicine is in anesthesia. In anesthesia, no 2 people really get the same dose. And even the same person coming back from multiple procedures often requires a different dosage. And a lot of times, for instance, in anesthesia, it might just be the function of how stressed were they the day before. Did their family come in to see them before they came into the operating room? Did they get a hug, or did they get a speeding ticket on the way to the clinic? All those sorts of things affect that. We like to think that that's somehow alternative medicine, and it's not relevant. It all has an effect because the brain controls the immune system, affects the body throughout whole, it affects the hormones, the homeostasis in the body. All of those things are factors. They're just difficult factors to measure, and so typically scientists and physicians like to avoid dealing with that. Those guidelines that I just mentioned to you are based on this initial study, pilot study that was done by Dr. Karriem back in 1998, published, which is looking at 3 different dosage levels of BioBran, RBAC. And at this lower level, which is 1 gram per day, and it's great being here in Europe where everybody understands grams, and I don't have to try and translate it somehow, like in the United States. There was no noted effect with respect to natural killer cell activity in the first week. At 1 month there was an effect, at 2 months there was an effect. The key point to take home from this graph is that out here at 2 months, there's essentially no difference in the natural killer cell activity, the change in natural killer cell activity between the people that are taking 1 gram a day and the people that are taking 3 grams a day. Okay? And so based on this pharmacokinetics, which is the basis of, is the scientific basis of dosing guidelines, then I make certain types of recommendations. For instance, a person like myself who is generally healthy but wants to maintain an optimal level of immune function, that person can start out at 1 gram a day, 4 capsules a day, and it's not a big deal. Why? Because I'm not fighting cancer. I'm not fighting off weird messages that I don't understand. I hope that doesn't say that the battery's dying. I'm not fighting any sort of imminent immune threat or health threat, okay? And so I have 2 months to get up to this point. But if you recall, I believe it was the study from Greece. They were taking 1 gram a day for 120 days, right? Well, 120 days, 4 months. So for the first 2 months, they were getting suboptimal therapy, okay? And for a very serious condition like HIV, I personally wouldn't want to put someone in that situation. I would want to give them the optimal therapy. So another point relating to that is when it comes to, if you allow me to help you with some ideas regarding case studies, always follow the science and never follow the dollars. That study should have been done at least at the 3 gram a day dose with 120 days. Saying that it's too expensive is a very poor excuse. And again, and I don't know to what extent in different countries the Hippocratic Oath is of any validity, and in the United States even it's not so valid. But one of the other aspects of the Hippocratic Oath is that money is never supposed to be a basis of decision making in medicine. You're never supposed to refuse someone care because they can't pay. And in this case, when you're giving the people the medication for free, it's a ridiculous concept. It's shameful thought for a person to have. The way to conduct that study would be to do the study for 120 days at this optimal dosage and recognize then what the optimal effect is. You have the greatest chance of success, and then you have the opportunity to see, does this work or does it not? Once you find out whether or not it works, then you can say, well, does it work at a smaller dose, smaller dose, smaller dose? It's the exact same way it's done in drug trials for pharmaceutical agents. You never start out and say, well, I don't know if insurance companies will cover this dosage, so let's start out seeing if this dosage is effective and spend $500 million on a suboptimal dose and have suboptimal results. That's how you lose your job and end up working on a farm. So in this case, you want to have the optimal dose for that whole period of time and then look at the data. The other aspect of it here, if you notice then at 2 grams and 3 grams a day for the first week, it's pretty much the same, but at 1 month, 3 grams a day appears to be advantageous over 2 grams a day. Now granted, there's no error bars on this graph, and I don't have access to the original data, but just taking it on face value, 3 grams a day is preferable over 2 grams a day for a person that has an acute or a serious specific health concern. Okay? You notice here I'm not saying cancer, I'm not saying AIDS, I'm not saying any of those things. I'm just referring to specific health concerns, because a health concern is a personal issue. It's not a medical issue, it's not regulated. It's a personal concern. So, how would I modify, for instance, those recommendations? One thing I just mentioned to someone recently was, for instance, a person who is generally healthy like myself, say some 20-something, 22-year-old college student who for the summer wants to travel for 3 months throughout Asia and go to India and Thailand and maybe go to Myanmar, Burma to see if they can help out with rescue operations, something like that, okay? They are about to put themselves at risk. Not because they're going to the third world, not because there's spicy food in India, but because they're going to a foreign environment. Every time you change environments, you encounter a different spectrum of antigens, if you will. In the old days, in the United States, they used to mock Mexico, and it was very non-scientific, even though one of my professors at Stanford used to do it. He was mentioned how you go to Mexico and drink the water and get diarrhea. It's not because of Mexico. because later, and especially as water quality around the world has gotten worse, I was so happy one day I saw an article in the San Francisco Chronicle, I think it was, where they were talking about tourists from Europe, specifically I think it was like Switzerland and Germany, who had come to the US, to San Francisco, drank the water and got sick. And I said yes, because I knew it's not about individual health standards, okay? Everyone's immune system is tailored to their health standards. Even if you live and you drink water out of the puddle in the ground like a dog, that dog's immune system is tailored to that health standard, okay? And if you drink water out of a faucet, or if you drink bottled water, all of those things, that's what we're accustomed to. And the difference is that as you go from place to place, the resident normal flora, the normal bacteria, are different in Cairo than they are in Delhi, than they are in Mexico City, Paris, Berlin, San Francisco, any of those places. They're different from place to place, okay? And that's really the biggest challenge, and that's one of the great things about eating yogurt. It gives you a fighting chance, but that's another talk. Anyway, so that's an important thing to keep in mind. And the other thing that they used to say was, you know, well, it's because people in Mexico don't wash their hands. And so for the next 4 years in medical school, I conducted a personal survey. Whenever I went to the bathroom, I would always watch to see whether the medical students and the physicians would wash their hands. And maybe 40% of people did. A large percent of the people didn't. When they're in clinic, they're more likely to wash their hands because they just come from a sick patient, and it's more of a conscious program. But in general, when I go from places to places, I was in Amsterdam airport the other day. I've continued this survey now for 20 years, I guess. People go into the bathroom and walk right out. Okay, it doesn't matter if you're in Amsterdam or if you're in Darfur. That human habit is very similar. There's some people that always wash their hands and some people don't, but it's not specific to race, culture, religion, nationality. So anyway, that person who is presently healthy and about to go into a condition of challenge, I would recommend them to start out before traveling. Say if they're going to travel here, I would say start here and start taking 2 or 3 grams a day. You know, even if you're 22 years old and you're a marathon runner and you're very healthy, swimmer or something like that, it doesn't matter, because you can, you know, go walking barefoot in India and get some sort of wild thing through your feet, and you just want your immune system in an optimal condition. So I look at this graph to let me know, you know, what kind of recommendation would I make, as opposed to just having a favorite dosage or favorite version. I rely on the scientific data. Now, one of the other aspects of BioBran that is exceptional, it's rare to the point of I'm not sure if I've ever seen it anyplace else, this sort of response in any other agent that has a pharmacologic activity. If you look here, this is another kind of informal study done by Dr. Karriem. 8 subjects that were breast cancer patients, presumably all women. Don't forget that men get breast cancer too, and it's actually more fatal, has a higher rate of fatality in men than in women. But starting out at baseline, again, natural killer cell activity having an increase, and along this timeline here, it's semi-annual. The first half of 95, second half of 95, 96, 97, 98, 99, all the way up to the first half of 2000. He measured natural killer cell activity in these people who were all taking, I'm not sure what the dosage was, whether they were on a maintenance dose of 1 gram a day or on 3 grams a day. But the important point is that at that dose, whether it was the 1 or the 3, they maintained this level of immune enhancement for the course of 5 years. That's outstanding, that's impressive, and I'll tell you why. Because the human body is not designed for homeostasis, it's not designed to have the same response to the same stimulus over and over again. A perfect example is drug addiction, or even sugar, which can also be an addiction. Whatever gives you the initial response, a person who's using heroin or using cocaine or eating, you know, sweet foods, that first dose level, whatever it is, gives you a certain experience. You will never get that same experience at the same dose, which is why drug addicts have to keep escalating their dose. Something that's more conventional, for instance, is cancer patients who are being treated for pain, and they're being given morphine and Demerol and other opiate drugs. they have to keep increasing that dose because the body becomes what they call resistant, but it becomes accustomed to that. That becomes its normal. And so the pain breaks through even at a high dose. Some cancer patients are on doses that would be enough to conduct open heart surgery on a person who doesn't take opiates, who doesn't take morphine, but because they've developed what's called tachyphylaxis, but they've developed a diminished response to that. If you stop giving it to them for a while, they come back to normal, and then you can give them that same dose, which is how often drug addicts will die after going to rehab, and then come back out, hang out with their friends, go back to using their usual dose, but it's now an overdose because their body is no longer used to that level. So here we're looking at 5 years where this effect is maintained over the course of 5 years, and it's very interesting to me that it cycles up and down. It has kind of a natural sinusoidal or wave-like pattern, which is the tendency of natural functions in the body. You don't just see a flat line. Scientists are always looking for a flat line, but the normalcy of hormone fluctuations and levels in the blood and all those things, they always have kind of this wave pattern like the ocean. Now, does everybody here know how this natural killer cell activity test works? Yes? No? You want me to explain it? Okay, I'll do a brief version of it. The way the natural killer cell activity works is that blood is drawn from the patient, and the natural killer cells are isolated from that blood sample. Those natural killer cells are put into a tube or a dish along with some cancer cells, usually called K562 cancer cells. It's just a standard cancer cell line that's sold to laboratories and to research houses. Regular natural killer cells are designed, by intrinsic design by the human body to attack and kill cancer cells, but they have a certain level of efficacy. And so when you look at, when you look at the activity, the slide's not moving. Oh, there we go. Okay. Here, for instance, it looks like it's about 15 where people started out on their baseline. Well, now it's catching up. Okay. And so what that means is that out of the cancer cells, usually you have a ratio of, say, for instance, 1 natural killer cell to 50 cancer cells. Okay, so you have a higher population of cancer cells than natural killer cells. And the natural killer cells at baseline in this group of people, in general, were able to kill about 15% of that overpopulation of cancer cells. Okay, so 85% were able to get away. And as you look over time, for instance, at the 2-month period, you're up here in the range of 70 to 75, which would be about a 5-fold increase, not just 300%. Okay. That's a 5-fold increase in the activity. And what that means is that from this same person, the same natural killer cells in general, because they're coming from the same person, they don't actually put the same cells in and pull them back out. But the natural killer cells from that same person now have 5 times the activity. What that means is they have 5 times the ability to eliminate cancer cells. Okay? And often when I talk about the immune system and how it works, and as we go through the talk, if I have enough time to get to that part of it, one way to think of it is as a security force. And I think our colleague from Greece mentioned something along those lines. And I use the same analogy. And so basically, it's like if you have, a cancer cell is like a terrorist cell in the body. And if you have a bunch of unarmed natural killer cells on your security force, they're not able to eliminate very many of those cells. The better armed they are, then the more effective they are per cell at killing these cancer cells. And I have some diagrams coming up to show that. So what does the science say about BioBran? And this is Dr. Karriem's study that Mr. Sasaki went through. And the basic conclusion of all of this data that I won't go into detail on is that the MGN-3, Dr. Karriem is still attached to the MGN-3 name, is an effective chemosensitizer and may represent a novel adjuvant for the treatment of breast cancer. That's just very polite scientific language to say that the effect of MGN-3 is to improve the overall efficacy of killing cancer cells in that person's body. In this case, they were actually also taking the drug daunorubicin, which is a toxic chemotherapeutic agent, and what was shown was that, as Mr. Sasaki showed in the graph, and I think it's coming up here, that the amount of drug that was necessary to kill the same amount of cells was decreased, which is an advantage to the patient and also therefore the doctor, because the less someone takes a toxic drug, the less toxic side effects that they have. This graph here is a log chart. These numbers along the bottom represent powers of 10 of the concentration of the drug daunorubicin. And so this is 10 to the minus 11th power, minus 10, minus 9, minus 8, minus 7, minus 6. That's important from the standpoint that if you look here, the distance from here to here, okay, is a distance of 10-fold. And so you have, as Mr. Sasaki mentioned, here's the IC50, which is the inhibitory concentration that reduces the cancer cell survival by 50%, from 100% down to 50%. And that concentration is roughly 1 times 10 to the minus 6, okay? And at this dosage here, you're almost at 1 times 10 to the minus 7. So that's about a 7-fold reduction in the concentration that's necessary for that drug, which then usually correlates with the amount of toxicity that the patient will have because they're being exposed to less toxic drug. So that 7-fold difference is not just 1 or doubled. Because this is a log graph, 10 to the minus 6 times 10, 10 to the minus 7. Okay, so this difference here is less than 10-fold, but it's very close, and so it's probably around 7-fold difference. So that's an important finding, even though it's in mice, but it's a helpful step forward to considering humans. And also, this is the same graph that Mr. Sasaki showed you that showed a 63% reduction in the size of the tumor. And again, that's important because that's what doctors use to gauge treatment success, is that the size of the tumor decreases. Yes?
Was this published already?
Yes. Yeah, this was published this year, and it's not letting me go back. It's published in a journal, I forgot the name of this, from this year, from 2008. This is data from one of the case studies that we conducted in the United States in conjunction with a health food store in New York State, and looking at 4 people that all had cancer, various forms of cancer, and here looking at what their NK activity changes were over the course of time. Now, this is a really good example of why it's important to have as many subjects as you can accommodate. Say 10 to 15 is